So this morning we're going to talk about React, and hopefully we'll get a good intro on it and see why it's getting a lot of buzz in the community. So what is React? React was actually an internal project at Facebook, and it was developed and then most recently open source sometime, I think, last year. And Facebook describes it as a JavaScript library for building user interfaces. So when you hear that, I know some of you might feel like this. Another JavaScript framework. Liam Neeson also doesn't appreciate it. React is also a library that implements unidirectional data flow. This is one area in which it sets itself apart from some of the more popular ones out there today. And what I think is the bread and butter of React is what they call the virtual DOM. And it's essentially a large JavaScript object that keeps track of the actual DOM. And that's what React uses to track changes and determine whether or not to actually make the action on the real DOM, because DOM operations are expensive. So they're trying to minimize that. So things that we're going to try to accomplish today, I'm going to quickly talk about JSX. And JSX is short for JavaScript XML notation. It's used by some people who build React applications. Then we're going to go over go over some sample code and build a contrived app to just get an idea of how React works. I'm going to quickly talk about immutable data and how it makes React fast. And finally, since a lot of our projects here at Solution Street use AngularJS, I figured it might be helpful to see how we can bring React into Angular, because because React makes no assumptions about the tech stack you're using, so it can easily be brought into whatever project you're working on. So, JSX. This has caused a lot of discussion in the community because typically we like to see markup, our templates kept separate from our display logic. But in reality, I think this quote, well, it says, "This coupling is real and it is unavoidable. We must bind event listeners to elements on the page. We must update elements on the page from our JavaScript. Our code must interact bidirectionally and in real time with the elements of the DOM." So that's just reality, right? That our applications are built so that our users can interface with them and get real-time updates. And so our logic and our markup is naturally sort of tied together. And so in React, what they're trying to implement is that each component brings together a particular business concern. And so, as you'll see in a minute, the JavaScript and what they call JSX is mixed together. So you'll see markup within your JavaScript file, and so that's sort of different and not really used in the past. But this also results in fewer files touched per change. So when you're implementing a code change for functionality for one particular component, for example, you are only touching that one file. And so that makes tracking changes easier and also eliminates the possibility of developing bugs. So the jury is still out. JSX is optional, so you don't have to use it. But a lot of people like it. People say it takes some getting used to, but there are pros and cons. So either way works. So we will go ahead and play with some code. So we're going to build a to-do list app, a contrived example. And so React is built based on components. So we're going to think of the app as a whole and think about what pieces need to need to exist so that this app makes sense. So within a to-do list, you have the container. So we have a to-do list container. We'll need a place to enter new items to our list. And then we'll need a list to keep track of those items. And within that list, we'll have items. So each one of these blocks is a component that we're going to build. And this keeps everything very organized, and all our logic for each particular component is kept separate. Okay, so we're going to start with this. Okay, so I have a pretty bare bones HTML file here. I'm gonna bring in Bootstrap, which I'll use later. I'm bringing in React, and in our body, I'm giving I have a div here with the ID to-do list, and this is the div on which I'm going to mount my component. So we'll get started. So what I'm going to build first is the to-do list container, and the to-do list container, we can here quickly give it a title. So to-do list app. And I'm going to quickly go over all this syntax. So in React, everything is a component. So every component has a render function, and this is the function that draws or builds the virtual DOM through which React will use to compare to the actual DOM to see if anything has been updated. So this is a very simple component, and I'm going to render it into page. So render to-do list. And then I'm going to give, so the first parameter I'm going to give it is the component or the class, which I just created, and the second parameter I'm going to give it is where the DOM element in get element by ID. Okay, so I'm giving it the element on which we're going to mount this component, which is this div right here. So let's see. Nothing.
Yeah, I think you had a case sensitive the to-do list on line 11. Should that be capital L at the end?
Right here?
Yeah, I don't remember what the div was.
No, I think that's
Is that H1 tag closed? That HI?
Oh, it's HI. Thank you. Okay. All right, so there we go. So now our to-do list component is mounted. Not doing very much, so let's continue. So we're going to now build the other components that we need. So we need an item input. So item input, we're going to make it a form. We'll make this a form, and we're going to have within this form 2 inputs. We're going to need a text field and we're going to need a button to submit the form. All right. And so now that we have this item input component, we can actually drop this into any other React components that we've previously built. So for example, I can drop item input right here. And this should give us our input and our submit button.
And the order doesn't matter there?
I'm sorry?
The order of the code doesn't matter there, that you have to define the item input first before you're using it?
Yep. So now that we have our item input, we'll need a list of items. So we're going to do item list here. And our item list will make an unordered list, and then it's going to have a bunch of children. And the children elements are going to be of our item. And our items are going to be list items. Okay, so now we have the bare bones structure of all the components that we need to build this app. Now let's talk about data. So these React components take data in one of two ways. There are these things called props, which are passed into the components, and there's also something called state. Props that are passed into a component don't change, whereas state is something that gets updated, which triggers this cycle of re-rendering and determining whether or not the DOM has changed. So for example, we're going to need to decide where to keep state, and a good place to do it is in our top level here, because we'll need to get data back from our item input and then pass it back down into our list. So there's a method called getInitialState, which returns an object which we'll give items, and we'll give it an empty array. But if you take this, so now this becomes the state of this component. So this state.items would be an empty array. So let's drop in our item list component here. And when we pass it a props, and props are passed down as attributes, so we can give it items equals, and it's passed in curly braces, this state.items, and for demo purposes, we're going to just populate this real quick and see that, oh, sorry, we haven't implemented anything down here yet. So in item, we're going to pass, so items, the array, our data is being passed down as items to the item list. And so in item list, we'll have the props as this.props.items. So what we're going to do is iterate over that. So var list is, or var display list is going to be this.props.map, this.props.items app. And then we're going to iterate over the array. So each item, I'm going to return an item component, and then I'm giving it the data. And so now the data is being passed down to the item component, and here in the item, I can display this.props.item. And so now, oh, I need to drop the array here. Okay, so now you see that the data is flowing from our top level component down through our item list, through the items prop. And then in the item list, as we're iterating over our data, we're going to pass that item, each item, down into the item component, which is then rendering it here. So now we need to figure out how to add an item to our list. So in our item input, we're going to take text, and when the submit action is fired, we need to have an event handler. And how we pass data back from a child component back to its parent is through a callback. So we're going to pass down a callback from the parent. So in the to-do list component, we're going to define a function, handle submit, and it's going to take an item, and it's going to update state. So this dot state dot items cat item. Okay. So now that we have this handler, this is going to handle the submit. So when the child passes the data back up, it's going to call this method, which will set the state to whatever the item is, and concatenating the item to our current state.items. So we're going to actually pass this method down to item input. So it'll be, we'll add this add item, and this is going to be this.handle submit. So now our input item has this callback, and we're going to bind that to this event on submit. So on submit, we're going to call this .props.add item, because add item is what we called it in this attribute here. So on submit, this callback will be called, and we're going to give it this .props.add item, and we need to give it the item. We actually need to create a method in this component which will handle submit, because we need to give the item back to the callback. So so this submit, now we'll call this here, this.handle submit, and it's going to receive an event, and we're going to disable the default submit event, and we're going to call the callback that was passed down. So this props.add item, and we're going to give it the value within the text field. And then after we've sent that, we've fired the callback, we're going to empty out the field. So target value. Okay. So on submitting the form, we're calling this method, and we're calling the callback that was passed down from the parent to-do list, giving it the value in the text field, which will take this item in and then concat it to our previous state. And after that, every time set state is called, the render function will be called, and the DOM will be updated accordingly. Something is broken.
Line 3.
Line 3.
The bracket.
Oh, thank you. Okay. Oh, so quickly, in what I have running here is a watch. It's basically compiling this JSX into plain JavaScript. So what that looks like is, give you an idea of what these elements that I'm building here, these components here are being compiled down to plain JavaScript. So some people prefer writing it in this fashion, but, some people think this syntax makes a lot of sense, when you're building it, so let's see, hello, what's going on? So, target value, submit function, what are we missing here?
So Wes, do you need both of those handle submits on line 12 and line 27? I'm just trying to understand it too. I don't know if that's a source of problem.
Because on line 12, you're passing, I guess I should have named them differently, but in line 12, you're passing this method, you're passing this method down into item input as a prop. And so in item input, the prop is now called add item. So this handle submit is actually pointing to this method. And when this is called, so they're different, if that answers your question.
So Wes, the handle submit on line 5 is really receiving the value, right, for the state, or updating the state?
Yes.
Is that correct? Okay.
Yep.
Maybe that clears it up a little bit. It's not really an event handler per se.
All right. What's happening here? This does set state of items dot cat. So it's not. All right. Let's see here.
Can you check the state after you submit and see if that item's been added to the state?
Yes, you can. And so, for example, this is the React DevTools, the Chrome extension that you can use, and it basically, excuse me, provides you with the virtual DOM essentially. And when you click on each component, you can see that the state here, my items isn't being updated properly because the array is still empty, and the reason is because I set state like this, but I need to set state of items to that. So I was setting state of nothing, essentially. So there we go. So now our list is working. So we're going to add one more piece of functionality, which is to remove an item from the list. And so what we're going to do is very similar to what we just did with the submit, and what we're going to do is handle remove. And also going to take an item, and what it's going to do is it's going to remove, it's going to take the item, iterate over that state, that items, that filter, and then we're going to iterate over our state items and return, let's make this to remove, item to remove does not equal item. So we're going to get a new array back called removed, which gives me all the items that didn't match the one that we want to remove. And then so we're going to this set state items is going to be removed. And that should do it. Okay, so now we have this method to handle the removal of an item, and we're going to pass it down through the list now because we want to give each item in the list this callback to call. So we're going to pass it down through the item list, and so we're going to give it remove item, and then we're going to give it this handle remove. And we're actually going to have to pass this down one more time because now it's in item list. We also have to give it to the items. So this is going to be remove item, and then this is going to be this dot props dot, what did I call it? Remove item. Okay. So now down in the item, we can then create a button that on click, we're going to fire this dot props dot remove item, and we're actually going to give it a partial function so that it doesn't fire immediately. And so we're prepending this method with this parameter so that when the click event is fired, it'll then call this dot props dot remove item with this parameter. And we actually need to make sure that because we're in a different scope here in the map, that we give it the proper this. So this needs to be this. So let's see. There it goes. Now I'll quickly show you, this probably doesn't look like what you want an app to look like in terms of styling. I'll quickly show you what styling looks like in this type of syntax. And so we're going to demo. So I mentioned earlier that I just included Bootstrap. So this is all Bootstrap. And so this is all well and good, but let me show you what it looks like in the code. So we need a demo styled. So there's also a lot of contention on whether or not, or how styles are handled when it comes to React. A lot of people are fighting for inline styling, but then people question whether or not that's reusable. But on the other hand, if we're going to build out CSS classes for these components, that then begs the question whether or not these components are really reusable outside of a given app context. But it really depends on your use case, I think. So for example, in a typical HTML tag, you would give the class as just class, but in React, you have to use class name because the class word is namespaced. And the only other thing that's really different is how you pass custom or inline styles into a tag. Where did I do that? Oh, for here. So when you give it a style, you actually give it an object, and a key value pairs of the CSS that you would typically give it. So that's really the only difference. And yeah, that's about it for the styling. So let's go back to our slides here. Okay. So now that we've looked at some code, I'm going to talk about the reconciliation process in React and what makes it fast. So every time a component has set state called or it's given new props, its component is marked as dirty, and then React will come and re-render the virtual DOM based on which components are marked dirty. And this will actually take every node that's marked dirty as well as its subtree. So if you're marking the top level node as dirty, then you're re-rendering the entire application, or the entire DOM essentially. But that's actually not too terrible because React is only re-rendering the virtual DOM, which is the JavaScript object, as a simple way to put it. And then it's going to diff that virtual DOM with the real DOM. So even if you re-render the entire app and nothing has changed, all you've really paid for is the re-rendering of the virtual DOM, because you're not going to React isn't going to make any updates to the actual DOM because it hasn't detected any changes. And then finally, it'll update the DOM nodes that are different. So we can actually make this faster by skipping these last three steps. So when a component is marked dirty, React actually has built in a method called should_component_update. And what we're going to do is essentially short the cycle or the loop, the event loop. And the default of the should_component_update is always true. So if you have a change in data or the component is marked dirty, then React will go ahead and re-render everything so that everything is properly updated in the DOM. But what we can do is we can help React out by throwing some logic in should_component_update and shorting and skipping the rendering call. And so instead of having subtrees that haven't changed, if your particular top level node has changed, you are now saving React from actually rebuilding the virtual DOM and skipping that portion of it. So that's all well and good, but JavaScript is a bit quirky, right? Let's take this block of code, for example. You have a string, and then you slice that string. The original text, the variable original text is still that string, and the chop text is what you expect it to be, right? And original text is still I'm a string and I'm immutable, but chop text is I'm immutable, and so as a result, the equality is false. So that's good. That's what you expect. But let's take this for example. We have an array of element 1, and we're going to take that first array, and we're going to push we're going to push 2 into it. And so what would you expect? If we're thinking in the same along the same lines as that first block of code, you would think that second equality would be true, right? Or that would be false, right? Because in that first example, it returns a new string, but in the second example, we're actually mutating or modifying our first array. So that's a problem, because in should_component_update, if we're comparing two objects and it returns true, then it's going to render even if our data hasn't really changed. And this is a good example, right? So if this.props.b is foobar, and A is being passed in as the next props, then you would expect what you would want to happen is that should component update would return false because those values are the same. So you don't want to re-render the component. And that's fine, right? That you don't want the component to re-render. But I'm sorry. So if the objects are coming in and they're the same value, you don't want to re-render. But this will re-render because they're two different references. They're references to two different objects. I'm sorry, I forgot that the operator in should component update is not equals equals. So in the same vein, for example, if our parent component is mutating state, and we're passing that state down into the child, that child has the same reference, that child's prop reference is referring to the same object that the parent state has. And so when we mutate state in a parent, that object that the child's pointing to is the same. So now in should component update, we're getting that there's no change when there really is change. And so then our DOM won't re-render, and so we won't see the new change in the component. Oh, yeah. So how do we fix that or address this problem? There are libraries out there that provide immutable data structures. And when you look at how immutable data structures work, it makes a lot of sense because every time you are modifying an object, you're getting back a new object with whatever action you took on it. So for example, a list is just a list of one, and list two is our first list, adding another element. So you see that list is a single element array, and list two is a two element array, and list one and list two is now false, whereas in our array.push, it was true because it was still pointing to the same object. And similarly, when it comes to objects, we're doing the same thing here. So previous is a record, name is Solution Street, and address is 427 Carlisle. If we take the previous and we set the address to 427 Carlisle, it'll be a no-op because it detects that there are no changes, so it returns the same pointer, so it's pointing to itself still. But if we take previous and set a new address, it'll notice the change, and then cur will be pointing to that new object reference. So previous and same, it's true, that makes sense, and previous and current is false, and which also makes sense. So we might think that this is a lot of copying, right? If we're creating a new object every time we mutate our data, then we're going to be doing a lot of copying. And deep copying is expensive. So how some of these immutable data libraries are fixing it or addressing it is something called structural sharing. And so this is a tree representation of our data. And let's say we want to add a node or add a value to our object. So traditionally, we would, in immutable data, we would just append that value to our previous object, and our reference to that top node is still the same. So this representation of our object no longer exists because our pointer to that top level node is still the same. So we've lost this, but we now have this. So how structural sharing does the copy is actually this. So it'll detect that we have a new node, and it'll only copy the nodes that it needs to be the same as the previous with just your mutation. So, for example, we added that bottom level node, and all it needs is its parent and that's parent, because our new pointer is now pointing to that top orange node, and we're still keeping the references to those nodes that haven't changed. So this is how these libraries are making the copying more efficient. So you're getting a lot of reuse out of the objects that haven't changed. So when this tree gets really complicated, you're not doing a deep copy of all your data. So finally, we'll quickly talk about how you can bring React into Angular. Most people compare React to an Angular directive, and this is how you actually bring React components into Angular most of the time. And so, for example, you have a div, and you give it the controller app controller, and then we're going to build a directive to-do list, and then we're giving it data. So in the directive, we're binding data. We're binding to the variable items, and in the link function, we're simply going to write a method that watches items, and as items changes, we are giving the new value to the React component, and then we're just forgetting about it. We're letting React do what it's good at, and React will go and figure out whether or not it needs to re-render the view. And so in this way, we're letting React do what React is good at, and we're using Angular for what it's good at, which is for its dependency injection, its ability to handle data, and so yeah. So it's really easy to do, and I'm sure this works in other frameworks as well. I haven't tried it, but and these are some links to some resources that are helpful. And that's it. You guys have any questions?
So, could you use React with? Do you need if you didn't have the immutable libraries, it would just mean that React is potentially rendering more often than it needs to.
So back on the reconciliation slide, so if you don't have the immutable data libraries, in should component update, you're basically comparing, let's say you're comparing data types that are easy to compare, like strings, numbers, Booleans. And so in those cases, you wouldn't need immutable libraries to handle that, because those are easy to compare in terms of how expensive they are. But when we get complex objects that we need to compare, then that's difficult to do because we can't compare by reference if we're not using immutable structures. We have to compare by value, and so we need to dig into however many levels deep our data has changed to determine whether or not should component update, right? And so that gets expensive, and should component update gets called a lot because React is always trying to re-render and keep your view up to date. So you want should component update to be very lightweight, and that's why a lot of people are suggesting immutable data structures as a way of doing it well.
And is there so that gets to functional programming, right? That's functional programming where you're returning, you're using immutable types. Is that true or false?
It's not necessarily functional programming. If you use immutable structures just as is, A functional program is essentially you're given inputs and you're getting outputs, and they're always the same, and there are no side effects. And that really comes into play when you're dealing with concurrency, where you're passing in an object, and an object is being touched from somewhere else, and then when you get the output, it's no longer what you expected it to be. But in the functional programming world, your inputs come in, and your outputs are always the same based on what your inputs are. I don't know if that answers your question.
Yeah. And this was the to-do app was one simple, well, it was one JS file. If you had an application with many pages,
Yep.
would each JS file be a component?
Yeah, that's how I've seen it. Yeah.
And now that you've done a lot of Angular JS, you've done a little React. If you were starting a new application, and I know it depends on what it would be, would you use React, Angular, the combination?
Yeah, I think that's a good question, and I think you're right that it depends. And like I said, like React does things well, that it does well, and which is updating the view and managing the DOM and being performant in that way. But libraries out there like Angular do other things well, right? And React is definitely not as comprehensive as Angular is, because a lot of people describe it just as the V in the MVC. It really is a little more than that, but that's what people describe it as, at least where it is currently. Yeah, I think it depends. But React is easy to throw in to whatever you're working on. So if you're running into performance issues in your views, then this could be a potential solution for whatever project you're working on.
Hey, Wesley, can you go back to the code for a second?
Yeah.
The question I had was, I have two questions. One gets to the very first thing Arthur had mentioned, which was the ordering of things. If you go to the bottom of this, or I guess maybe if you go to the app demo simple one, it might be a little easier. The very bottom is where you're calling the react.render. Does that call have to happen after your components have been defined?
That is a good question. Let's try it. Yes.
Okay. And then the second question I had was with regard to state. I see in a bunch of, when we were modifying the list of items, you were always kind of doing a set state call. And I'm curious, is there the equivalent? Is there a get state? And if there's a get state, could you do a get state call, throw that into an object, and then just modify that object and have it just work? Or do you have to call set state?
Well, you call set state, and the event loop starts when set state is called. So it's I've read that it's frowned upon for you to mutate state directly. So this dot state dot items equals this, because that sidesteps React's way of doing things, and the render wouldn't be called if you set state in that way.
Okay, yeah, that answers my question. And then the third thing is that the correct answer to Arthur's last question was you would use Meteor and then figure out which components of Meteor you needed to use.
I have a question, maybe a dumb question. I didn't think you were allowed to just like put HTML inside of JavaScript.
Yeah, oh, maybe you weren't here for,
Sorry, you missed the first part.
I was 2 minutes late.
yeah, that's okay. So let me pull that slide back up. Yeah, I was
Can I
saying that-
partially answer that to see if I understand what's going on?
Sure.
Because my understanding is that the JavaScript you're writing here actually gets
Compiled.
rendered into what I would call real JavaScript. So you're
Yep.
writing JSX files, and then if you bring up that JavaScript file that it got rendered as, that's the actual JavaScript that's being run in the browser. So you're not, like, I was confused at first when you wrote it because I was seeing this HTML and I'm thinking, what? That's not really an object. How is that an actual argument to an array, to a function? But then when you showed this, it kind of made a little sense. And that's not the same as I think maybe the question that was asked, which was more of a philosophical question. But that was just my understanding of how this actually is working.
Yeah.
Okay, so it's pre-compiling it
Yep.
into JavaScript.
Yep.
And
Right.
that's done just by using the library? It's like smart enough, like on the fly? Is
Oh,
that-
no, I'm running a watch.
Ah, okay.
Yeah.
So you have to have a background pre-compiler that's like basically constantly converting it into the thing you're actually using.
Yeah, well, if you're in a real project, you would do it when you're pushing code or during your build process, probably. But
Well, you probably need to do it all
In
the time.
development,
Every time you're coding, you.
Yeah, that's
It's gotta
true.
get
Yep.
recompiled.
yeah, and so I was just communicating that JSX is optional when building React apps, but a lot of people like this syntax because it makes a lot of sense.
Right.
But then there are people who aren't as comfortable seeing XML markup in your JavaScript, and so this is what it looks like if you don't want it.
So you can code it this way if you like.
Yeah, so your React.create element, you're passing in the HTML tag,
Yep.
you're passing it in props, any styles, and then the last argument is children.
So it's
I wonder,
almost-
is there any way to templatize what you've done in your JSX? In other words, have your JSX and then have those places where you're using that, HTML/XML as a separate file that can be, imported in place.
You mean
It's just-
keeping the
HTML in separate files.
separate file? I haven't seen that.
Okay.
Yeah, because I think the idea behind how they built this was to keep all of it together.
Right. No, I understand. I think just as a person completely new to it and not having
Yep.
looked at it or worked on it, it's jarring.
Oh, yeah.
Angular 2 does that.
Mm.
Yeah, Angular 2, I think, does that with web components, where you do what you're talking about, Jeff, which is you externalize your HTML to a separate file.
When are those defined like this state? Is there a top level React object,
Yes.
a root level object?
Mhm.